Yo, what's up guys, and today I'm going to be talking more about my data registers, specifically entering a formula. As I've said before, I want to be able to give data to my registers in three different ways. I want to be able to give just a normal number, the value inside another register, and a formula combining the two using four of the main operations: addition, subtraction, multiplication, and division. Now let's talk about how I actually combine these numbers, and it might be simpler than you think. First of all, I would want to choose the register that I'm going to store my data to, and I explained how this works last video. And all it really comes down to is translating one hexadecimal number into four binary bits. Even though I'm adding formulas, there are still two ways to get my numbers. I can convert a two-digit hexadecimal number into a binary number, or I can grab the value inside of another register. Now, all I need to do is ignore the sign in the middle and just do this process twice, and then I have my two numbers. Then, once I have my numbers, I can go back and look at my sign and perform the specific operation. Addition and subtraction are very easy because they are built into my ALU. But more complex operations like multiplication and division are not. So I need to actually code multiplication and division into my computer. But how would I do this? Let's start by looking at how to do multiplication. The simplest idea is that multiplication is repeated addition, but this can take a very long time with very large numbers, even when it should be easy. So I want to go about this with a little more advanced approach. When in school you were working with larger numbers, you were probably taught to do multiplication like this. We would first multiply all the digits in the 123 by the 5 in the 45. Then we go to the 4 in 45. But before multiplying anything, we add a 0. We would multiply the 4 by all the digits in the 123, and then once we have our two numbers at the bottom, we will add them up. Well, how can we turn this into binary? Let's start by multiplying two very simple numbers. Let's multiply 3011 by 5101. So first we're going to take the first digit of the 101 and multiply it by the top number. And if you guys are noticing, multiplying a number by 1 is simply just that number. We would then go to the next line, and like we did with normal multiplication, we would add 1 0. And as you guys all know, multiplying something by 0 is just 0. We would go to the next line, and instead of adding 1 0, we would add 2 zeros. And then we add everything together to get our result, 15. I think that we can have three major takeaways from this. We add a 0 for each digit that we shift to the left. Like I showed you guys, for each line, we add a 0. If the digit we're looking at is 1, just put the number. And if the digit is 0, put nothing. Let's look at how my multiplication actually works in my computer. It uses three registers. Two of these are the numbers in the equation, and the final one is the output. Let's load a random scenario, 3 times 5. First, we're going to look at the value inside R1, which is 5. Particularly, we're looking at the first digit, which in this case is a 1. Now, remember our second rule. If the digit we're looking at is 1, we're going to add the number. So we're taking the number from R0 and adding it to R2. Just like the first rule, every single digit we move over, we have to add a 0 to the number. So we're going to shift the value in R0 to the left, effectively adding a 0. Then, to view the next digit of our number in R1, we're going to have to shift it to the right one. So now the second digit becomes the first digit. We then repeat this process. We look at the first number of R1 and we see it is a 0, so we don't add anything to R2. Then we shift the value in R0 to the left and shift the value in R1 to the right. We repeat the process again. We see that there's a 1 in R1, so we add the value in R0 to R2, and then we shift. Instead of this repeating 8 times, I made it so that whenever R1 is equal to 0, it stops and outputs R2. And this is exactly how my computer evaluates these formulas. Unfortunately, I have not finished the division yet. I do have the algorithm, but I haven't put it to code yet, so I'm going to save that for next video. So stay tuned for the kind of second part of this video where I finish the division, and peace.